Now let's see this question. Let f of x equal to x into mod x for x belongs to real numbers, then f of x at x equal to 0 is. So they are talking about the point x equal to 0 and they are given us the function, and now the options are continuous, differentiable, continuous, not differentiable, differentiable but not continuous, neither differentiable nor continuous. See, directly by looking at it, you can eliminate option C, isn't it? Why? There cannot be any function which is differentiable but not continuous, isn't it? So you can use this diagram. Now if this is the set of all differential functions which are differentiable, and if this is set of all continuous functions, there cannot be any function which is differentiable which is not continuous, right? Therefore you can directly eliminate it. Okay, now what about option A? Can a function be both continuous and differentiable? Yes, right? So examples are here, all the functions which fall here. Now can a function be continuous and not differentiable? Yes, examples are all functions which fall here. It can be continuous but not differentiable, right? Can a function be neither differentiable nor continuous? Yes, because the set of all functions is not just set of all continuous functions. If you say this is set of all functions, right, there can be some functions which are neither continuous nor differentiable, right? And now one more thing, while going for this, if you find out that, see, let us say answer is D, then how could you know that where to stop the solution is, once you find out that a function is not continuous, there you can stop it and say that it is neither differentiable nor continuous. You need not go and check whether it is differentiable or not. Why? If the function happens to be not continuous, then definitely it is not differentiable also, right? You need not go and check for it again. Got it? So option C is not possible, and in case if the answer would have been option D, then it turns out that the continuous function is not continuous. You can stop the solution there, right? So that is how you can solve these questions. Let's go in and go and see this function first. Now f of x equal to x into mod x is given. We have to find out whether it is continuous or not, right, at a point 0. So we want to know how the function behaves when x is less than 0, when x is greater than 0, and when x is equal to 0. Why? Because we are interested in finding out the left hand limit and the right hand limit and the value of the function at that point. Now if you observe it, at x is less than 0, what happens to this? When x is less than 0, right, then if x is a negative number, you can assume that x is a negative number. If I remove this mod, the output should be a positive number, isn't it? If x is negative, if I remove this mod, if the output has to be positive number, you have to multiply it with -1. Therefore, when x is less than 0, you have to multiply this x with -1 if you are going to remove this mod. In that case, it is going to be minus x square. Got it? That is why when x is less than 0, it is going to be minus x square. Now when x is greater than 0, which means x is positive number, now if you remove this, then you need not multiply with any negative sign. The reason is, if I remove this, the number is going to be positive only. Only thing you should remember is, whenever I remove this mod sign, the result whatever you get should be a positive number, right? In case if this is a negative number, multiply with -1. In case if it is a positive number, leave it as it is, right? Since x is greater than 0 means x is a positive number. If I remove this mod sign, just leave it as it is. That is why when x is greater than 0, it is going to be x square only. Now what happens when x equal to 0? It is going to be 0, right? Okay. Now if you observe it, we have to find out the left hand limit. Now what is left hand limit? Left hand limit means what happens to the function when the value is just less than 0. When the value is just less than 0, this is the function which you are going to use. So left hand limit is nothing but limit extends to 0 minus x square. Why minus x square? Because we are talking about a point which is just to the left of it, which means left of 0 means negative number. So I am using this one. Now you are going to substitute in place of x as 0. So it is going to be 0. Now what about right hand limit? I am talking about a point where that point is just to the right of 0, which means a positive number. So whenever x is positive, the function is going to be x square, right? So x square I am going to use here. Anyway, when you substitute in place of x 0, this one is going to be 0 and this one is going to be 0, and also the value at x equal to 0 is going to be 0 already, right? Because of this 0, irrespective of what happens here, when you substitute 0 here, it is entire thing is going to be 0, right? So all these three are equal. Left hand limit is equal to right hand limit is equal to f of 0. So we can say that the function is continuous. Now we found out the function is continuous. Can we stop the solution here? No. The reason is there can be functions which can be continuous but which are not differentiable, which means now it is, since it is continuous, A or B both are equally probable. We don't know which one it is, right? Now as we have already seen that it is continuous, we can apply that shortcut. What is it? When a function is continuous, you can find out f dash of x and then f dash of a minus and a plus. If you can find it out, you can directly solve it. So what I mean to say is, in order to find out the differentiability, you need not go and find out left derivative and right derivative and find the values. That is a long method, right? Since it is already continuous, just find out what is f dash of x. Now here if you find out f dash of x, it is going to be mod x plus mod x, which means you are going to get 2 into mod x. This is what you are going to get as f dash of x for this one, right? Now try to find out what the value of f dash at 0 minus, this is nothing but the left hand limit, and try to find out what the value of f dash at 0 plus, which is nothing but right hand derivative. Sorry, it is left hand derivative and it is right hand derivative. Left derivative and right derivative, we have to find these two. Now how to find these two is, find out what will be this function when it is less than 0, x is less than 0, and find out what this function when it is greater than 0. So you can write it this way: f dash of x is equal to, when x is less than 0. So what does it mean? If x is negative, if I remove this mod sign, then the result has to be positive. That is why you are going to multiply with minus 1. Therefore it is going to be minus 2x, right? Now what happens when x is positive? When x is positive, if x is positive, now if you remove this mod sign, the output is also going to be positive. Therefore let it be 2x only. Got it? Okay. Now if you have to find out the value of f dash of x at 0 minus, you are going to use this function. In this function you are going to substitute at x equal to 0, right? So what will you get? 0. Now if you have to find this value at at a positive value, which means 0 plus, then you have to use this function, and in place of x you have to substitute 0. Anyway you are going to get 0. Therefore since these two are equal, we can say that it is differentiable. So that is a shortcut. Since I explained you, it might have taken some time, but if you do it, it is going to be a shortcut really. So this is going to be continuous and differentiable. Now even though we have seen the shortcut, let's see the actual method also, because there will be some functions which you might not be sure whether they are continuous or not. If you are directly doing without checking for continuity, then you might have to follow this method, right? So what is it? Now left derivative is going to be limit h tends to 0 minus f of 0 minus h minus f of 0 divided by minus h. It is going to be minus h square. So see this. Why minus h square is, you are going to substitute in place of x minus h. So minus h into mod minus h. We know that h is a positive number, which is a small positive number, right? So now if you substitute h a positive number, you are going to have, let's say h is a small number which is close to 0, right? We need not write h 0 minus and 0 plus. Okay. Now if you see this, h is a positive number which is close to 0. Now if you write like this, f of 0 minus h, which means in place of x you are supposed to substitute minus h. So here if I substitute minus h, it is going to be minus h into mod minus h. Mod minus h is going to be h only, and outside there is minus h, therefore minus h into h is going to be minus h square. So you got minus h square, right? And f of 0 is, we already know it is 0 divided by minus h, so which is going to be h. And since limit h tends to 0 is there, which means in place of h you are supposed to substitute 0, you are going to get 0 in the output, right? So therefore the left side derivative, the left derivative is going to be 0. Now what about right derivative? In right derivative, limit h tends to 0, f of 0 plus h minus f of 0 divided by h. Now h is a positive number and if you substitute h here, it is going to be h into mod h. So since h is positive, you need not multiply with minus number, right? So it is going to be h square only. So h square by h, which is nothing but h, and since there is limit h tends to 0, in place of h if you substitute 0, the output is going to be 0. So the left derivative and right derivative both are equal to 0. Got it? Therefore, you can also say that by this method also you can say that it is differentiable at 0. So when to use this shortcut and when to use this method is whenever you know that the function is already continuous, then you can go for the shortcut. Now if you are not comfortable with this method and if you always want to use this method, so be sure that before applying this method, find out whether the function is continuous or not. It must be simple, and after that you apply this method if it is continuous. If it is not continuous, then you can there only you can say that the function is not differentiable as well. Are you getting this? So what is the simple method is find out whether the function is continuous or not, right? Now see, even though the question is asked about differentiability, you can do it this way. Find out whether the function is continuous or not. If it is continuous, if it is not continuous. In case if it is not continuous, then you can say that it is not differentiable also. In case if it is continuous, then you can apply shortcut and you can find out whether it is differentiable or not. Got it? Okay. Otherwise, if you directly want to find out about differentiability or derivability without talking about continuity, then you can directly use this method without worrying about whether it is continuous or not. That is up to you. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.